Welcome to Chemistry Simplified. The topic we'll discuss today is strong acids. So, what determines the strength of an acid? So, an acid is said to be strong based on how much hydronium ion it can produce in solution. So, a strong acid is able to produce many moles of hydronium ions in solution. Why? Because the strong acid can donate its proton easily. So if you dissolve a strong acid in solution, it would dissociate to produce hydronium ion in solution. So let's look at a generic example of a strong acid. Let's say we have Ha. Let's say this is a strong acid. If it was to dissolve in water, it would dissociate completely, almost completely, to produce hydronium ion and A minus. We say A minus would be its conjugate base. If you don't know what we mean by conjugate base, we had a previous lecture where we had talked about acid and conjugate bases. So you could go and review that lecture. So HA is a strong acid, so therefore we expect it to dissociate almost completely in solution, almost 100% in solution. Meaning that at the end of the reaction, we should only have hydronium ion and the conjugate base, which is A minus in solution. Because a strong acid would dissolve or dissociate or ionize completely in solution, so that even though you begin with the strong acid, at the end of the reaction, mostly what it's left, it's the hydronium ion and the conjugate base of the acid. A strong acid is a strong electrolyte, right? So any acid that's said to be strong are considered to be strong electrolyte. However, strong acid produce weak conjugate bases. Very important. So if an acid is strong, it will produce weak conjugate bases. And if we have a strong acid, the forward reaction is favored, meaning that it's more likely will be producing products than reactants, meaning that the strong acid will dissociate completely. So at the end of the reaction, there won't be much of the acid left except for hydronium ion and its conjugate base. So let's look at a list of the strong acid. So the strongest among the acid would be hydroiodic acid, HI. Next we have hydrobromic acid. Then we have perchloric acid. Then hydrochloric acid, sulfuric acid, and lastly we have nitric acid. So these are the strong acids. So we have 6 strong acids. The strength of the acid increases as we move up, meaning that hydroiodic acid would be the strongest of these acids, but they're all strong acids. Let's look at an example. Let's say we have nitric acid, which is a strong acid. If that was to dissolve in water, it would dissociate completely to produce hydronium ion and nitrate ion. That would be the conjugate base of that acid. So nitric acid dissociate almost completely because it's a strong acid. And at the end of the reaction, we expect to find mostly hydronium ion and nitrate ion in solution. Why? Because the forward reaction is favored, and we expect nitrate ion to be a weak conjugate base. Let's look at one last example. Let's say we were to have hydrochloric acid, dissolve that in water. It would ionize, dissolve, or dissociate completely to produce hydronium ion and chloride ion, which would be the conjugate base. So hydrochloric acid would dissociate almost completely because it's a strong acid. And at the end of the reaction, we would find mostly hydronium ion and chloride ion in the solution because the forward reaction is favored. And lastly, we would say that chloride ion is a weak conjugate base because it's from a strong acid. This is the end of our presentation. Please let us know in the comment section how did you find it, if you found it to be useful. And remember to like, subscribe, and share. Thank you. Bye bye.